Mr. Rabbit here, and time for another boring diagram explanation. Obviously, you have a world map here, and the key concept that we're working with in this diagram is latitude and longitude. So I hope you know that latitude and longitude is a coordinate system. Okay, it allows us to pinpoint locations on the planet. So when you start with latitude and longitude, obviously you have to begin with the reference lines. Everything starts from some point. Okay, I'm going to highlight the reference line for latitude. So I'm using the yellow line to show you the equator. So the equator is the reference line, or 0 degrees for latitude, separates the Earth into the northern and the southern hemisphere. When I look here, I am highlighting the reference line for longitude. So that line is the prime meridian. So the prime meridian is 0 degrees of longitude. You should know right up here it runs through Greenwich, England. So sometimes they call the time at the prime meridian Greenwich Mean Time. Now, this map is really nice because on the sides it tells you which numbers are associated with longitude and latitude, but sometimes they won't do that. One trick that you can always use is if you find the direction that a value increases, that's describing the direction of measurement. So if I look at this 40, the numbers are increasing as I head east. So these are going to be measured in degrees east. This 80, okay, is west of the prime meridian, but the numbers are going to increase as you move further west. So those would be degrees west. So whichever direction the values increase is going to be the direction that they are measured. All right, for now, I'd like you to write over here the 4 points that are on this map. A, B, C, and D. We will come back to finding those coordinates after we have discussed the system a little bit more. So when you flatten a map, like the top projection, you'll see that it somewhat distorts the lines of latitude and longitude. So a better model for actually looking at these lines are these models on the bottom. Now, looking at this one, where the lines are parallel to each other, they never intersect. This would be a depiction of latitude on a sphere. The name for latitude lines are called parallels because they never intersect. You should know they are measured in degrees north or degrees south of the equator. So your latitude lines are north and south. Even though they run east to west, they're measured north or south of the equator. Now, the maximum latitude that you can go to is 90 degrees. If you're at 90 degrees north or 90 degrees south, you're going to be at the poles. Now, other lines of latitude that we will deal with. Okay, there are two lines, one in the northern hemisphere, one in the southern hemisphere. You have the Tropic of Capricorn and the Tropic of Cancer. Now I wrote them the other way. N comes first. N is alphabetically before P. If you're trying to remember these, Capricorn is at 23.5 degrees north, while Cancer is at 23.5 degrees south. You might ask yourself, where does that number come from? The 23.5 degrees is actually equal to the tilt of the Earth's axis. Now, two other circles. You have the Arctic and the Antarctic circle. If you do 90 minus 23.5 degrees, what you get is 66.5 degrees. So the Arctic is 66.5 degrees north, and the Antarctic is 66.5 degrees south. So that's your latitude system. It looks like circles when viewed from above. Now, if you look at the projections over here, obviously this is longitude. The general name for lines of longitude is, they're called meridians. Okay. Is this taping? Yes, it is. Good. All right, so you have meridians of longitude. It's measured in degrees east or degrees west of the prime meridian. As I said, you should definitely know that runs through Greenwich, England. Now, the maximum value is up to 180 degrees. When you're looking at a side view, the equatorial or side view is going to give you 12 hours of time. But when you look up down at the poles, you're seeing the full 360 degrees. So this one gives you 24 hours of time. If you look down on the poles, you're seeing the entire northern hemisphere. You'd see all 24 hours of time. Now, one thing that we're going to deal with longitude is you should know that changing your longitude changes the time. Essentially, 15 degrees of longitude is equal to a 1 hour difference in time. And we will have some other boring diagrams to take a look at how we would do those problems. Now, let's slip back up to our map and see if we can find the coordinates. Honestly, the easiest one to do is going to be point D, because it's right at the intersection of a parallel and a meridian. To read the latitude, you always start at the equator, and I'm going to move in the direction to find the point. So we're moving north to find point D. I follow this line, and it's 60 degrees north. You put the latitude before the longitude, just like you put X before Y, latitude goes before longitude. Now, I start from the prime meridian, and I move across. I ask myself, what direction is this going? Okay, this is definitely to the east. I look at the top, and that meridian is 60 degrees east longitude. So that point, 60 north, 60 east would be in the northern hemisphere and the eastern hemisphere. I hope you know how to make your own compass rose. You do north and south, and then west to east going across. All right, the other ones, A is north. Now, you've got to estimate how many degrees. This is much closer to 30, but it's not quite 30. So for A, I would say 25 degrees north. If I'm looking at the longitude, I'm starting from the prime meridian. I have to go west. Here's the number on the line. These numbers increase as you go across. So point A has to be, no wiggle room, 100 degrees west. Now, B is in South America, but it's not on an exact parallel or an exact meridian, so you have to estimate it. Starting from the equator, I'm moving south, so the latitude is going to be degrees south. Starting from the prime meridian, I'm moving west, so this would be degrees west. Now, to me, when I'm going south, this looks about 2/3 of the way down, so I'd say 20 degrees south latitude. It's between 40 and 60, but it's definitely closer to 60. It's not halfway in the middle. So let's estimate at 55 degrees west. Okay, point C is on the equator, which would be 0 degrees. There's no north or south because you're on the reference line. When you're looking at your longitude, you start from the prime meridian, you travel east So this is going to be degrees east, and it's a little bit more than 20. So let's just estimate that as 25 degrees east. Hopefully you know what latitude and longitude is, and you can use it on a map to pinpoint or find a location on the Earth's surface. Hope this helps.